Hi everyone, I am Madhumita Ananda and I am pursuing my Masters with the Department of Electrical and Computer Engineering in University of Florida. This project was submitted in partial fulfillment of the course Image Processing and Computer Vision for fall 2016. The main project is a generic currency converter, and the project prototype implements the currency symbol and numerical character recognition part of the bigger product. The following topics are addressed in the slides: the problem under study, the motivation on why this problem was chosen, what parts of the bigger product or the idea the project prototype implements, existing work in the area, how the new proposal will add value to the existing work is explained the proposal part. Then it explains the image processing operations used in the actual implementation, that is image pre-processing and character recognition. It also includes future scope, conclusion and references. Problem under study: traveling has become an inherent part of our everyday lives and everyone travels a lot. When we travel, we come across different currencies because of changing geographical locations. We often find the need to convert between a foreign currency to home currency. For understanding or visualizing the value of a commodity, we also need currency conversion for sending and receiving money between different countries. Manual conversion of currency is time consuming and also takes up a lot of resources. Simple scenario which brought me the idea of implementing such a product or creating such a product is that I am in a new country, and whenever to buy a commodity, I end up converting the foreign currency back into my home currency, which is very time consuming. The problem of manual conversion of currency could be automated by developing an application that could take image as an input, and based on the currency symbol and the numeric characters in the image, it would convert it into the target currency type specified in the application. It also can include a field for input currency type if the currency symbol is not present in the image. Overall objective and motivation: the overall motivation of this project proposal is to develop a comprehensive product which will be a portable application that could be installed on a mobile device or a tablet device, that could detect commodity prices from price tags, offer boards, currency notes, or handwritten currency symbol and numeric value, and convert it into an output currency type that has been selected. In case a currency symbol is not present in the image, an option to select input currency type would also be included. This would be a comprehensive product which provides solution to all character recognition tasks, including alphanumeric characters, currency symbols, and this could also be extended for paper currency recognition and currency rate conversion. Project prototype: the project prototype implements the currency symbol and numeric character recognition part of the overall picture. The project prototype primarily has two parts. One is the image pre-processing part, where different image filtering, morphological operations, transformations has been applied on the images to isolate only the required part of the image to perform a recognition operation. Currency symbol and numerical recognition is performed on the pre-processed image by correlating the image with a gallery set. The sample of the gallery set used is shown on the slide. It contains numbers, alphabets, and also currency symbols with a black background with the characters in white. The size of the images in the gallery is basically 24 cross 42 logical. Existing work in the field: there already exists a mobile application for paper currency recognition. The working of it can be viewed in the link provided in the slide. There also exists some IEEE papers on implementation of optical character recognition in mobile and server-based environments. Proposal: this proposal will add value to the existing work as follows, which I'll explain right now. The product proposed will combine the applications which are already existing That is, it aims on developing a comprehensive application that combines optical character recognition, currency symbol recognition, and paper currency recognition into a single application. Other than providing comprehensive character recognition application, it will also perform currency conversion. The project prototype implements or looks in detail into a new concept, that is currency symbol detection. Usually in character recognition projects, the prime focus will be alphabet recognition or number recognition. Here the main component that is looked upon is currency symbol recognition, and should be currently it's implemented only for the dollar sign, and it could be extended to all other currency symbols. Project flow contains two major components: image pre-processing and character recognition. Image pre-processing part actually contains experimentation with different denoising techniques, image transformation techniques, sharpening techniques, and morphological operation. Two or more techniques for each procedure is compared, and by trial and error, the technique which gives the best solution is chosen for performing that image processing operation. The finally processed image, uh, after extraction of the required part, is used for character recognition. Character recognition primarily involves segmentation of the pre-processed image and then mapping it to uh, the gallery images by computing correlation between the probe set and the gallery set. The probe set is primarily the segmented images. Based on the mapping, classification is performed. The first step in pre-processing, that the input image is an RGB image which includes red, blue and green components. Directly processing this image will put a burden of us processing three different elements. In order to overcome this, the RGB image is converted to a grayscale image which just contains pixels percentages of white and black, making processing easier. The primary step in any image processing application is denoising. Image denoising was done using a mean and median filter. Mean filter is a linear technique in which a processing element or a structuring element is moved over the original image as windows, and mean filter replaces the middle pixel of the intersection of the structuring element and the image with the mean of the neighboring pixel. On the other hand, median filter is the same, but it replaces the center pixel with the median of all the surrounding neighboring pixels. Thus median filter is non-linear. On implementation, it was seen that median filter provided much better results than a mean filter. Mean filter averages out both noise and required data. On the other hand, median filter enhances required components and eliminate noise. Median filter also provides better brightness. So median filter was preferred over the mean filter. The next step is image sharpening. Image sharpening was done using a mask where an identity image is subtracted from the original image. Another type of image sharpening was done using bi-orthogonal wavelet transform. Bi-orthogonal wavelet transform is a modification of the orthogonal wavelet transform, except that it has more degrees of freedom, such that the mask can be applied, or the structuring element can be applied in multiple directions like 0, 90 and 360, etc. As the orthogonal wavelet should be invertible, but doesn't necessarily needs to be orthogonal to any of the image axis. Orthogonal or a wavelet transform enhances the particular frequency components in the image that are required, rather than performing some kind of averaging operation on the image with the wall, because averaging operation can affect both noise data or unwanted and wanted data. A wavelet transform basically performs a medium pass or low pass and removes noise which has high frequency and enhances the required frequency components to produce a more sharpened image as shown on the slide. The next step is thresholding, which involves converting the grayscale and denoised image into a binary image containing only black and white pixels. A mask is then constructed in order to isolate only the required area from the binary image. The mask dimensions are taken according to the dimensions of the string in the binary image. It takes the value of the far left, far right, furthest top and furthest bottom pixels of the text area and uses that as dimensions to construct a mask, and that is used for and add some value to each of it, and finally constructs a mask that only isolates the required part of the image. The next step is image inversion. Here image inversion is performed so that the image matches the gallery set, but the background is in black and characters in white. The image inversion operation is again followed by a masking operation. This masking operation is done by performing an OR operation between the mask and the image. This is done to make the background uniform, that is to fill it with zeros or black. We can see that there are still some components in the image that should be removed that are unwanted on top of the numbers and the currency symbol. The next step is edge detection. Edge detection was tried using Canny and Sobel operators. Canny edge detection is a comprehensive technique which involves noise removal, non-maximal suppression of unwanted frequencies, and hysteresis thresholding, which boosts the gradient at the boundaries to avoid false edges, etc. In addition to the actual edge detection application, Sobel edge detector is nothing but a discrete differentiation operator that is applied over the whole image, and it marks the pixels as edges at points where the image pixel intensity is abruptly changing. Because the comprehensive nature, Canny edge detection produces better results, but because of the processing overhead, it consumes more time and resources. Canny edge detection can be replaced by Sobel edge detection in cases where the noise in the image isn't very high, as Sobel edge detection is more prone to noise. In this case, image denoising is already done, and the peak signal to noise ratio, which is a measure of how strong the signal is with respect to noise, is higher than 95%. The Sobel edge detection has been used instead of Canny edge detection. The next step is morphological operations in the data. Initially, the data was converted to grayscale. Denoising was done, converted to a binary image, and a mask was used to separate out required part of the image. Image sharpening was done, and edge detection. The next step is edge dilation. Edge dilation is used to fill pixels in the object boundaries to make up for discontinuities in the image. Here edge dilation is performed twice, and the dilation, the image after second dilation is shown in the slide. Dilation is performed twice. At the first dilation, usually doesn't eliminate all discontinuities in the boundaries of the image. Hole filling is a morphological technique in which a structuring element is moved over an image. It is not necessarily square. It fills once in the area between the detected edges, and in other words, it colors the area within the detected edges of the image. Edge dilation and filling are used in conjunction in this case. A processed binary image is calculated by subtracting edge dilated image 1 from edge filled image 1. It can be seen that the inside of the filling of the binary processed image represents our symbol and character accurately and has eliminated jagged edges that were initially present around the character. This can be used for optimum character comparison and recognition. The next step in image pre-processing is image opening. Image opening is used to eliminate further discontinuities in the image and remove jagged edges. Here a structuring element of 25 ones is used in different directions, 0, 90, 45, 135 degrees, and opened images are shown on the slide. All these opened images are combined to form a single opened image. This single opened image is subtracted from our binary processed image to obtain a finally fully connected image, as shown in the slide. Uh, it can be seen that the image contains unwanted components or pixel values that are not required, that it will be eliminated in the next step. The next step in image pre-processing is removing unwanted so this is the removal of small objects. This is done using the criterion that all objects in the image with fewer than 200 pixels are removed, so that only the large connected components remain. This is the final pre-processed image that will be used for character recognition. Uh, Next part of the prototype is the character recognition part. Median filtering is done again on the image in order to smoothen out the image further and to remove jagged edges. The image segmentation. Image segmentation is found by first computing the or detecting the various fully connected objects in the median filtered image. A loop is used to navigate across all the fully connected objects, and the fully connected objects detected are stored in variables. These variables are then resized to 24 cross 42 to match the size of the images in the gallery set. These resized and connected components are then displayed, and they are the segmented images. Actual numeric character and currency symbol recognition. The segmented characters form the probe set. So a correlation operation is performed and correlation values are computed for each pair of images in the probe set and the gallery set. A character is assigned to each of the segmented images based on which pair has the highest correlation value. Character recognition results that are obtained or saved to a text file as shown. The future scope of the project. This implementation of the prototype could be developed to a larger portable application which can address all character recognition tasks from alphanumeric characters, currency symbols, handwritten and printed, and also paper currencies. A dedicated graphical interface which accepts an input and output currency type could be accepted. This will also provide real-time currency conversion application. In conclusion, image pre-processing plays a very important role in any image processing application. The proposed project prototype actually experiments with different image filtering and transformation techniques, and based on trial and error and comparison with other techniques, uses the techniques that produce the best result. Accuracy is not very high in this application. Accuracy could be increased by adding more images to the gallery set to compensate for changes in font and handwritten characters. Accuracy could also be increased by including more adaptive filtering steps in the pre-processing part. These are the references used in the project. I would like to thank Professor Dr. Wu for helping out with the completion of the project and the course, and the various references that helped me out with the implementation of the project. Let me show a demo of my code. This is my code. Let me run it. It shows all the images that I described in the presentation. This will be the final image or pre-processed image that will be used for recognition. It's median filtered again. These are the segmented characters, and that is the image recognition file. This is a walkthrough of my code. The first part deals with loading an image for processing. It is then converted to a grayscale image. A mean filter and median filter were compared, and the results were compared. It was seen that median filter provides better results. Median filter is used for denoising. Image sharpening is done using a bi-orthogonal wavelet transform. A mask is designed based on the edges or the top left, extreme top, bottom, left and right pixels of this numeric part or the string part in the image. The mask design is used to extract only the required part in the image. Then it is the grayscale and denoised image is converted to a binary image. A mask is then applied over the binary image to make the whole background black. The binary masked image is then inverted so that to get a black background. For matching with the gallery images, mask is applied again on the inverted binary image to isolate only the required part of the image. Edge detection is done using canny edge detection. It takes some amount of computation time. PSNR has been computed and it does not show any error. So Sobel edge detection has been used to replace canny edge detection. Image dilation is then performed with two different structural components. Image dilation is performed twice. Image filling is performed on the second edge dilated image. Edge dilation, as I said before, is performed twice to eliminate all discontinuities in the boundaries of the image. The process binary image is obtained by subtraction of the edge filled image and the first dilated image. The process binary image provides a smooth filling inside edges. Edge filling is performed on the image again. Image opening is done by using four structuring elements of structuring elements 0, 90, 45 and 135. All the opening operations are combined to form a single opened image. This single opened image is subtracted from the binary processed image obtained earlier to get a smooth, sharp and crisp image with the characters in the image having no jagged edges. The extra or unwanted objects in the image are removed by removing all the pixels fewer than 200 pixels. The currency symbol and currency character performs is done by filtering the image again and performing some more pre-processing. The number of the size of the template is noted. All the black and white pixels in the image of interest are labeled. Image segmentation is done by computing all the connected components in the image. Then traversing is done across the connected components and each one is resized to match the gallery set image dimensions of 42 cross 24. These images are displayed. A correlation, the read letter function computes correlation between each of the segmented images and the gallery set images and compares the obtained labels with the actual labels and returns the corresponding character with the highest correlation. The results are printed out onto the Word file. Thank you for watching. This is my project proposal and submission.